Assalamualaikum dan selamat sejahtera. Saya Fitri Saira binti Sulaiman daripada Grup 5 akan membentangkan projek Elektronik Prinsipal 2. Saya Fitri Saira binti Sulaiman, nombor matrik CN 11004.
Hi and Assalamualaikum. My name is Fathana Nazar binti Ramli and I will continue with introduction. The key component for this project is thermistor, which has been used to detect the rise in temperature. Thermistor is a temperature sensitive resistor which resistance change according to the temperature. There are two types of thermistor, which is NTC or negative temperature coefficient and PTC or positive temperature coefficient. For this project, we are using NTC or negative temperature coefficient type. Okay, NTC thermistor is a resistor which resistance decrease as temperature, while in PTC it will increase the resistance as temperature.
Okay, next I will continue with literature review. Okay, for this project we are using two types of OM. First one is non-everything and another one is voltage follower. Okay, for non-everything, in non-everything operational amplifier configuration, the input voltage signal Vin is applied directly to the non-everything or plus input terminal, which means that the output gain of the amplifier becomes positive in value in contrast to the inverting amplifier circuit. Okay, for our voltage follower, a voltage follower is an OM circuit which has a voltage gain of 1. The reason it is called a voltage follower is because the output voltage directly follow the input voltage. Okay, purpose of a voltage follower is an OM circuit is a circuit with a very high input impedance. This high input impedance is the reason voltage follower are used.
Project scope. This project to monitor temperature using a thermistor temperature sensor and turn on an LED warning when the temperature exceeds 52 Celsius. When the temperature exceeds 52 Celsius, the voltage across the thermistor will decrease, causing the voltage at the ADC input to increase. This can be detected using a microcontroller or comparator, which can turn on an LED warning. NTC thermistor can typically measure or monitor temperature from negative 80 Celsius to positive 150 Celsius. Other than that, it can be used to monitor the temperature within various environments, such as in the food and beverage industry.
Hello, my name is Shamila. My matric number CN210014. Today I will present about the circuit diagram. The circuit diagram that we use in project. We use two op-amp. First is voltage follower, second is non-everything op-amp. Okay, for first voltage follower op-amp section is connected by R1, NTC, R2 and R3. For R1 we use 200 ohm. For NTC 1.5 kilo ohm. For R2 we use 220 ohm. And lastly for R3 we use 1.5 kilo. And second, for non-inverting op-amp, which consists of two resistors with the value 3 kilo ohm and 1.5 kilo ohm is connected to the ground at negative terminal of op-amp. Hello, today I will present about the circuit diagram. Circuit diagram that we already do in Proteus. This is the circuit diagram for my project. For this project, we get thermistor, and then resistor 1, resistance 2 and resistance 3. And we also have DC voltage, and for V in we use 5 volt. And then we have two op amp. First is voltage follower, second is non-inverting op amp. And also we have warning LED, and also we have RF and R6. For RF we use 3 kilo ohm and R6 is 1.5 kilo ohm. Okay, and then you can see when we run the program, okay, the first for the meters that we set is negative 55 degree, and then you can see when the degree is up until 55 degree, the warning LED will on. To start 52, LED will on until 400 degree, and then the V out is 1.8. V out for voltage follower will same as DC voltage, and then for V out LED we get 3.57.
Okay, my name is Muhammad Nasimi Sulaiman, and I will explain for the calculation and simulation. Okay, this is the graph for the difference in calculation and simulation. As you can see, for the voltage follower and non-inverting op amp, that is the same except for the just decimal places. But for the Western bridge, we have the calculation of 1.1381, but for the simulation is 1.19. There is a difference because in the simulation we use the different types of NTC, so that there is some slight difference from the calculation. Okay, now I will explain in detail for the calculation. Okay, so firstly, the calculation for the Whetstone bridge, we have the V in 5 volt, R2, R3, R4 and RT1. To calculate for the Whetstone bridge, we need to apply the KCL at node B and node D. After that, we need to find the Thevenin impedance by shorting the voltage. So we get the ZTH equals to Z2 parallel with Z3 plus Z1 parallel to Z4. And then we replace the Z value to R value, we get the ETH formula. V in times R2 over R2 plus R3 minus RT over R1 plus R4. Before we use the formula ETH, we need to find the RT1 value, that is the thermistor value. We use the formula 1.5 exponent times beta times 1 over T minus 1 over 298.15. The T is for the temperature in Kelvin. Beta is the material constant for the NTC that we use, that is 3528. We insert the value to the formula, we get 0.56151 K. Then go back to the formula of ETH. We can substitute the RT value, so we get 1.13810 volt. So now for the voltage follower, the voltage follower is straightforward because the V out is equal to V in, so we get 1.19 volt. For the current, we use V out over RL, so that 1.19 over 1K, we get 1.19 milliamp. Okay, this is for the non-inverting op amp. We have the RF 3K and R5 1.15K, and our V in 1.1895 volt. We use the formula V out 1 plus RF over RI times V in. We substitute above our value, we get the V out 3.585 volt. Okay, that's all for me. Thank you.
Okay, next conclusion. In conclusion, a project on thermistor monitoring using OM could explore the different type of thermistor, their characteristic and application. The project could delve into the working principle of thermistor and how they depend on temperature, thermistor circuit and self-heating application of thermistor using OM. The project could explore the use of thermistor in different applications such as temperature monitoring, fire alarm, liquid flow measurement, liquid level detection, and air flow measurement. So that's all from us. Thank you.